Okay, this is our Merleau Ponty reading group. We are continuing our reading of Structure of Behavior. We are on chapter 3, if I'm not mistaken. Yes, 3 of these long chapters of the book. So we have been off for a few weeks. So I don't have like sort of fresh in my memory exactly what we talked about last time, but so this whole chapter is about these three sort of orders of explanation or orders of reality, the physical, vital, and human orders. And the idea or the sort of question guiding this chapter is like, what is the relationship between these different orders of reality? So like maybe a more like mainstream way of understanding this would be that the physical order is the fundamental one, and then the vital and human orders would be sort of in principle reducible to the physical order. So everything having to do with living beings, for example, is some sort of complicated description of a physical system. Living beings are physical entities, and any sort of biological process is, in principle, composed of like all this sort of complicated interaction of physical processes, etc. But that's of course not going to be Merleau-Ponty's analysis of the relationship between these different orders, and he also looks at the sort of isomorphism account that the Gestalt psychologists had proposed. So this is the idea. So it's not exactly a reductionism. It's not like sort of trying to like I don't know, identify, say, like neural mechanisms that are responsible for visual perception, for example. But what it does, what this sort of Gestalt psychology isomorphism account wants to do is to show how the same kinds of principles operate in the perceived world as in the physical world. So like the sort of standard example of this is the way that a soap bubble takes on a spherical shape just by minimizing surface tension. A sphere is the shape that has the smallest area for a given volume. So if the sort of regulating principle that governs the evolution of the soap bubble system is minimizing surface tension, then it just forms a sphere just as a result of the sort of functioning of that system, and not because someone decided that a sphere is a good shape for a bubble to have or something like that. And then likewise, in our visual perception, there are these good forms that the Gestalt psychologists had identified. So a circle or a sphere is obviously a good form in the sense that this is like a sort of natural resting place. It looks sort of symmetric and stable, whereas if you take a circle and sort of deform it slightly, bend it or whatever, then it looks sort of misshapen and like off balance. It has this sort of tension in terms of like the visual structure of the scene. So it doesn't just look like a certain curve with whatever properties. It looks like a circle that has been bent. And yeah, so the idea is that like we can sort of within the perceptual world find these principles governing what types of shapes are good shapes or have this like property of being stable, and then we would hopefully be able to identify these kinds of principles operating within the perceptual world and in the physical world, and the idea is that the ultimately they're like the same principles just sort of operating in different domains. So like the kinds of sort of dynamics of shapes in the world of experience would ultimately be brought about through the dynamical properties of the nervous system. There'd be some sort of complicated evolution of states in your brain that would sort of be the correlate of the evolution of the shapes in visual perception, for example. What Merleau-Ponty is going to sort of object to this, or like his, I guess, different orientation towards this kind of problem is that this it's kind of not going far enough in terms of the use of this concept of form that the Gestalt psychologists had identified. So there's this notion of form as this like intrinsic grasp of structure, in the sense that you don't sort of start from these atomic elements that have no internal structure of their own and then sort of combine them together and put them together into some kind of structure. You instead have this sort of intrinsic grasp of a structure at the outset, which doesn't depend on first grasping something structureless and then assigning it a structure. So this is what this notion of form has to do, and like stated in sort of the most abstract form. But then when we look at this relationship between these different orders, the physical and the vital, for example, Merleau Ponty is going to argue that the sort of Gestalt psychology explanation is effectively not using that notion of form. It's still starting from these two sort of self-contained orders. They're treated as atoms essentially, and then trying to figure out how they combine with each other, rather than having this sort of form, this grasp of the relationship between these two orders in terms of the notion of form. So we identify this notion of form within the vital order or within the world of experience, but then we want to use this notion of form to understand how that vital order is related to the physical order. So that's sort of like the guiding hypothesis or the guiding project of this chapter and of his sort of alternative way of understanding the relationship between these two orders. That's sort of like a more general overview, not exactly what we talked about last time, but that's sort of the bigger picture of what this chapter is doing. So yeah, I think we can sort of pick up from there and move on to the reading for this week. So if someone wants to pick up from page 150, I think we were at the beginning of the larger text, like outside the sort of smaller text section. So thus the dialectic.
I can read. Thus the dialectic proper to the organism, the milieu by catastrophe, the organism momentarily reduced to the condition of the physical system. But it is a question here of pathological laboratory. These remarks hold against mechanistic physiology. They also apply to Gestalt theory. Perceptual reactions can be explained by model only in the case in which they are artificially isolated.
Angus, sorry.
Yeah.
You're cutting out for me and for Bats. Could you try like disconnecting and reconnecting? And we'll just wait a minute or two for you to come back.
Yeah, 1 second.
I'm sorry about that. We'll pick up again from the same starting point. And Leif Mason, in the recording, you can cut this part out.
Can you hear me?
It's good for now. Yeah.
Okay. I think just give it a shot. It might be.
Oh, sorry. It's cutting out again.
All right. Let me just try. Can you hear me?
Keep going.
I'm gonna try.
No, I think it's still cutting out.
Okay. Can you hear me now?
Keep going.
Okay, I'll try it on my computer. I was using my phone, so maybe it'll be better.
Yeah, it's better for now. Yeah, so far. Okay, yeah, do you want to pick up from the same spot again, and we'll
I'll
again
start at the beginning. Thus, the dialectic proper to the organism and the milieu can be interrupted by quote-unquote catastrophic behavior, and the organism momentarily reduced to the conditions of the physical system. How are we doing on sound? But it is okay, cool. But it is a question here of pathological cases or of laboratory phenomena. These remarks hold not only against a mechanistic physiology, they also apply to Gestalt theory. Perceptual reactions can be explained by physical models only in the case in which they are artificially isolated from the context of action in which they are naturally integrated. Then the privilege of certain forms, instead of expressing the natural mode of action of the organism considered, depends only on the objective character of the stimuli presented. But these structures, not being centered in the total activity of the organism, are either label formations, that is, pathological, precisely like Rubens' equivocal figures, or else the process of physical equilibration from which one tries to make them emerge can itself unfold without interruption, only with the guarantee and the guard of the total activity of the nervous system. Wertheimer's laws relate the formation of structures to the objective conditions in which the stimuli are presented, law of proximity, law of qualitative resemblance, or to the stability of quote-unquote good forms, considered as a property which is inherent in them. If it happens that our perception indeed obeys these laws, it is not because it is assimilable to a physical structure. It is because the functioning of the nervous system, in spite of the perpetual interactions of which it is the seat, is organized in such a way that Wertheimer's laws can work, In other words, it is because he had the good fortune of encountering constants in them, which are admitted by the total activity of the organism. It is Gestalt's own principles which we are invoking against it here. In a form, the whole is not the sum of its parts. Even if one accepts the fact that the organism is accessible to a physical analysis which is unlimited in principle, since no one contests the fact that the physico-chemical analysis of the organism is the most complex there is, it is absolutely certain that these structures will not be able to find their equivalent in physical structures in the restricted sense of the word. To construct a physical model of the organism would be to construct an organism. The physical models of Gestalt theory have just as little relationship to the phenomena of life as crystallization has to karyokinesis. We are upholding no species of vitalism whatsoever here. We do not mean that the analysis of the living body encounters a limit in irreducible vital forces. We mean only that the reactions of an organism are understandable and predictable only if we conceive of them not as muscular contractions which unfold in the body, but as acts which are addressed to a certain milieu, present or virtual. The act of taking a bait, of walking around a goal, of running away from danger. The object of biology is evidently not to study all of the reactions which can be obtained with the living body in any conditions whatsoever, but only those which are its reactions, or as one says, quote-unquote, adequate reactions. Everything which can occur to an organism in the laboratory is not a biological reality. One is not trying to do physics in the living being, but rather the physics of the living being. In other words, one is attempting to trace the contour of a quote-unquote natural behavior, which must be disengaged from a de facto behavior, which is to say that quote-unquote organism is an equivocal expression. There is the organism considered as a segment of matter, as an assemblage of real parts juxtaposed in space, which exist outside of each other, as a sum of physical and chemical actions. All the events which unfold in this organism possess the same degree of reality, and there is not, for example, the distinction between the normal and the pathological. Is this the true organism, the sole objective representation of the organism? In reality, the body thus understood is neither the object of biology nor even of physiology. I don't remember exactly what the point he was making in the last couple of paragraphs was, but what he seems to be saying here is that the vital behavior only approximates physical behavior when there's some kind of pathological condition, and that I think that when he's criticizing Gestalt theory here, what he's criticizing is isomorphism, and what he's saying is that, at least as I understand it, you can't understand these vital behaviors if you building up from nested physical forms, because these behaviors, like walking towards a goal, have a unity which I guess his point is can't really be explained in terms of the physico-chemical reactions happening in the body, which is walking towards a goal. And then this object of biology is not just everything that can happen to the body of the organism, but the organism as it interacts with its milieu. Just because some chemical interaction can be effectuated with respect to the body of some animal, it doesn't mean that it's biologically relevant.
Yeah, I think that's right. This is also connected to some like ideas and discussions that have come up in more recent philosophy of biology. Around this idea of teleology and the notion of a function in biology. So, like in sort of you could call it, I guess, naive biology. Like biologists just sort of doing their work without thinking, specifically about like what exactly the conceptual structure of their work is. That they'll always talk about like the function of an organ or some physiological process or whatever, and this function concept is sort of intrinsically teleological, or at least apparently teleological concept, in the sense that like the function of a heart is to pump blood, and without a heart, an organism would not be able to circulate nutrients and so on. But of course, the sort of background understanding of most biologists is not that there was like some intention behind putting a heart in the organism to to make sure that it would be able to circulate its nutrients. But there's some sort of evolutionary explanation or whatever. But more generally, like when we want to understand what it is for something to be like the functioning of an organ, for example, we can't sort of reduce that to like say a statistical property of like say like this organ does X most of the time, because there are some cases, and maybe even the most common case, where the if you look at the actual manifestation of some property, it doesn't perform its function most of the time. So like there are some insects, for example, that will lay thousands of eggs, that and then only a handful of those eggs will actually survive, and the larva will eventually become an adult form and then reproduce. So in some sense, the whole life cycle is like the norm, that like the egg will turn into larval form, which then turns into the adult form and then reproduces. That's like normal. That's sort of like the normal functioning of the organism, in some sense. But if just in a statistical sense, the vast majority of those eggs will die or be eaten or whatever, long before they can ever mature into an adult organism that can reproduce. So like the only way to identify that this development from the egg into the adult form and reproduction, and laying new eggs is like normal, or like the sort of the real function of this whole process. It involves some sort of understanding of the biological process of something, something that is not actually sort of present as a something that is given in space, in this sort of mechanistic sense. So like if you only look at what actually happens, and then do statistical analyses of these properties of these organisms as they're given in space, you would never be able to identify this life cycle as like part of the functioning of the organism. So yeah, so what he's suggesting here is that this is like not just sort of an exceptional case, but this is like intrinsic to biological processes and the vital order in general, is that we can only ever it requires a different kind of intellectual grasp to understand something as part of an organism's life, compared to understanding something as a physical or chemical process occurring in space. So yeah, we can never like understand something in its biological signification just by like identifying how these processes are occurring in space and time. Okay, we can go on to the next bit. Someone else would like to read from page 152, this method of organization.
Yeah, I can read.
I think we're on 151.
Yeah, on if we could describe, I think.
Oh, really? Oh, my, wrong. Oh, okay, sorry, yeah. If we could describe, yeah, thanks.
Okay. If we could describe the innumerable physical and chemical actions which make a living being pass from adolescence to adulthood, we would have a continuous sequence of phenomena in which it would be difficult to recognize the duration of an organism. The typical quote-unquote functions or quote-unquote processes, for example, anagesis and katagenesis, the rhythm of which defines the phenomenon of growth or of aging for the physiologist, linked to change of chemical reactions which condition them from all sides, would lose their proper contours, their individuality, to such an extent that the characteristic modifications which they undergo with age would cease to be perceptible. A total molecular analysis would dissolve the structure of the functions of the organism into the undivided mass of banal physical and chemical reactions. Life is not therefore the sum of these reactions. In order to make a living organism reappear, starting from these reactions, one must trace lines of cleavage in them, choose points of view from which certain ensembles receive a common signification and appear, for example, as phenomena of quote-unquote assimilation, or as components of a open quotes function of reproduction in quotes. One must choose points of view from which certain sequences of events until then submerged in a continuous becoming, are distinguished for the observer as quote-unquote phases, growth, adulthood, of organic development. One must mentally detach certain partitive phenomena from their real context and subsume them under an idea which is not contained, but expressed in them. Open quotes. The meaning of the organism is its being, end quotes. And the organism which biological analysis is concerned with is an ideal unity. This method of organization of experience is not exclusive to biological knowledge. In history, to understand is also to break up the global ensemble of concrete events according to categories, then attempt to rejoin the real unity from which one has started by establishing concordances or derivations from one order to the other, from the political to the economic, from the economic to the cultural. It is also in a becoming which is inarticulated at the molecular level to mark breaks and phases. It is also in a becoming which is inarticulated at the molecular level to mark breaks and phases, the end of one world and the beginning of another. I don't understand the sentence, but okay, I'm gonna keep going. The structures which one arrives at in this way are, as are those in the organism, neither supplementary causes which would direct the partitive phenomena, nor simple names for designating them, but ideas in which they participate without the ideas being contained in them. Open quote. Supply and quote unquote demand are neither real forces hidden behind the special causes which determine the production in each factory and the consumption of each individual, nor simple names for designating the arithmetical sum of these local phenomena, but objects of thought which science constructs and which give the immanent significance and truth of events. It is not otherwise that the history of the planets, is written, or that the ages of the Earth are made to emerge through a continuous molecular evolution. Do I finish here or do I keep going?
Yeah, we can stop here. I think that's probably a good point.
Okay.
Yeah, so this is so he's sort of extending this idea of this like sort of grasp of the meaning of something, beyond just the biological or the sphere of biology as a science, but this is something that's characteristic of pretty much any, like even physics or like a mechanical explanation is still involves some sort of like intellectual construction. It's not just sort of like sort of the Francis Bacon's account of science was that it would just be the sort of pure induction. You would just observe a bunch of things, and then like the correct account would just sort of emerge naturally out of this summative series of observations. And of course, that's not like a very realistic account of what you're doing when you do science. You don't just observe random things. You perform certain experiments to try to isolate a certain phenomenon that you're interested in, or you visit a certain place because you're interested in the plants that grow in that place or whatever. Like you make deliberate decisions as to what things you want to observe, and then of course when after you've done the observations or while you're doing the observations, you are trying to understand what it is you're doing. You don't just sort of passively receive the observations and then grasp the what the process is just by adding together a bunch of individual observations. So you come up with theories of how this process works. You might develop a mathematical or a computer simulation of the process. You might build like even a physical model of the process, like a smaller scale model of like how a volcano functions or something like that. So there's all sorts of intellectual work that goes into grasping any aspect of the world that you're trying to understand, and this work means that so we have to sort of, there's like two opposed misunderstandings of this kind of work. So the one would be that these sort of elements of a scientific account of a certain phenomenon would be like these sort of parts of the world or aspects of the world, like so his example here of supply and demand. So it would be like if you sort of treat supply and demand as like these forces that are acting on people, that like I decide to make more widgets in my factory because this force of supply is pushing me, or the force of demand is pulling me to make these more widgets, which of course is sort of a mythological explanation. It's not a real account of economic decision making. And then the other error would be like sort of the opposite error, which would be that like supply is just a name that we use to sort of add up all the different decisions that go into the the total amount of widgets that are produced in a certain economic unit. So like the word supply, the word demand, these are just sort of names that we apply to like a sum of like individual units. So these are the sort of the two opposite errors that we need to avoid. We need to have an understanding of supply and demand, for example, as like grasping something real about the world insofar as it is structured into an economy, without treating supply and demand as like something additional added on to like the decisions of individual people in terms of what actions they're going to perform, building widgets or whatever. So there's some sort of supply and demand exist at the level of meaning of like something that is imminent to the decision making of the people, but is also not sort of reducible to like a sum of those decisions. So it's a little bit mysterious or hard to situate this sort of level of meaning without falling into one of these errors or the other. But that's sort of what it's like how to make sense of this position that is neither these mysterious forces acting on the world, nor just a summation of like sort of atomic individuals. So that's trying to sort of thread the needle between those two errors is what we're trying to do in this part of the book.
I could continue. Where did we get to?
Yeah, so I'm just waiting for Bats to supply and demand. Yeah, so, like this. Oh, sorry.
Okay.
I'm just gonna sort of respond to Bats' comment here before we move on. Yeah, so of course, like supply and demand is an especially I guess easy one for people to fall into one of these errors or the other, where like people that like I don't know did like an economics 101 class in university and then never like did anything after that will be like, oh, it's just sort of simple economics or whatever. So like of course the supply of X is going to if the supply of X is lower, then the price will be higher, etc. And of course there are many other factors that intervene in setting the price of a commodity, and these there can be like a sort of reverse feedback of one on the other and so on. So anyway, obviously these things are much more complicated than the sort of very simplistic picture. But like, having this very simplistic understanding of like the supply and demand curves and then where they meet is like where the price is set. This sort of encourages this notion of like supply and demand as like these sort of mysterious forces that are like pushing people or pulling people to take a certain job or move to a different region because there are more job opportunities or whatever. The linen coat thing. Yeah, exactly. But yeah, so like these very simplistic accounts sort of lend themselves to this idea of like these mysterious forces that are like hidden behind the observable reality. And then maybe the opposite side would be like if you think that I don't know, economic decision making is like too complicated to understand in like this sort of very detailed way. You might say like, oh, we just have to do everything statistically. So we would just be like, I don't know, what's the average income of so many people, and what's the average amount that they spend on X or whatever, and just sort of multiply these averages or sums across the population, and then sort of just like look at what is the correlation, for example, between like I don't know the average wages in a certain region and then the rent for housing in that region or something like that. You just sort of correlate these numbers with each other, but you have no account for like how these numbers are actually related to each other. What sort of processes bring about the connection from one to the other? So this is like the opposite error, where you just sort of look at the numbers and like try to find correlations between them, but you have no like understanding of what actual processes or structures are involved in bringing about these correlations. I think these sort of two opposite errors are quite prevalent in specifically in the domain of economics. But you can probably identify like the same kind of pair of opposite errors in pretty much any like field of study. Okay, so 61, if you want to read the next bit. So we're at the bottom of 152 at it is impossible.
Okay, it is impossible for the intellect to compose images of the organism on the basis of partitive physical and chemical phenomena. And nevertheless, life is not a special cause. In biology as well as in physics, the structures must be submitted to an analysis which finds in them the combined action of laws. What we are looking for in the idea of life, quote, is not the terminal stone of a building, but the building itself in which the partial phenomena, at first insignificant, appear as belonging to a unitary, ordered, and relatively constant formation of structure. We are not looking for a real foundation, or Seinsgrund, which constitutes being, but for an idea, a reason and knowledge, or Erkenntnis, in virtue of which all the particular facts become intelligible. It is necessary only to accept the fact that the physico-chemical actions of which the organism is in a certain manner composed, instead of unfolding in parallel and independent sequences as the anatomical spirit would want, instead of intermingling in a totality in which everything would depend on everything and in which no cleavage would be possible, are constituted, following Hegel's expression, in cluster or in relatively stable vortices. The structures of being in such a way that the mechanism is accompanied by a dialect. Should I continue?
Yeah, you can keep going. Thanks.
Okay, but we not brought back to the classical alternative. If one grants that physical and chemical phenomena can only intelligibly depend on conditions which are themselves physical and chemical, and therefore that this physico-chemical analysis is in principle unlimited, do not the properly vital category, the sexual object, the alimentary object, the nest, and the modes of conduct directed towards these objects cease to be intrinsic denominations of behavior in the organism? Do they not belong rather to our human way of perceiving them? And in the final analysis, ought not constructions of stimuli and reflexes be substituted for them in an objective study? Descriptive biology would be a preliminary inventory of the superstructures which are supported by the physics of living things, and explanation in biology, as well as in physics, would have to be reduced to the type of explanation by laws, the characteristics of the organic individual, the property which it has of itself setting the conditions of its equilibrium, then of creating its milieu, would be only the macroscopic result of a multitude of elementary acts identical to those of physical. Explanation could in principle be coextensive description. One would have to grant only that in biology as well as in an exhaustive analysis of the de facto structure, the physical and chemical actions in which we decompose a function can themselves be only stable content. Thus the laws explain a given structure only by producing another structure, and in this sense the physics of the organism is also obliged to start with a certain, quote, historical given. But it does not differ from the other physics, and the structures of the organism would be only a particular case of those of the physical.
Thanks. Yeah, we can stop here. So this is sort of developing this idea of this opposition between these two opposite errors. And so the part we just read is looking at the one sort of error, the sort of reductionist error, and then the next bit will be on the opposite error of this idea of extra forces acting on things. This idea here, you can do the same kind of error or the same kind of reduction at any level of explanation. So even if you say, for example, biology would not be reducible to physics because of maybe the complexity of biological phenomena, you say that biology, so one possible position would be biology is in principle reducible to physics. There's nothing sort of extra added on to physical and chemical properties that make something alive. But biological phenomena are too complicated to, in practice, actually perform this kind of reduction. So, if you wanted to give an explanation of what it means for an organism to, find a sexual partner and reproduce, trying to explain this purely in terms of the motions of different chemicals across membranes in its cells, for example, would be so immensely complicated that it's not actually worthwhile. So that's one sort of possible position. But this you can still do this kind of error, this kind of reductionist error, even if you sort of stay at the level of biology and sort of deny that it's actually in practice possible to perform this reduction to the physical level. So even at the level of biology, you could say that these concepts that we use in sort of naturalistic description of animal behavior, that like the animal is looking for food, or the animal is looking for a mate, or trying to flee a predator. These sort of descriptions of an animal's behavior in terms of the meaning, or like what goals it's pursuing, and so on. These are sort of anthropomorphic descriptions, and then we should, in principle, we should substitute a more sort of objective description. And so we could say that the animal, ran in this direction, or the animal, climbed this tree, or whatever. Like, describe the movements of the animal without sort of attributing any like goals or intentions to the animal. So that would be one way of sort of reproducing this error, but within the level of biological description, as opposed to reducing biology to the physical level. But yeah, so it's again the same kind of error, because you are, well, for one thing, you can only do this description if you sort of presuppose a certain like stability of the environment. So like maybe you can like substitute. So your sort of natural description of an organism might be in terms of looking for food, and then you might be able to like swap that language for like a more supposedly objective language, and describe the motions of the organism. But this is only possible if you have like a certain like if the organism is in a certain kind of environment in which it's capable, for example, of recognizing what items are food and which ones are not. If you present the organism with like a completely different environment that is completely unfamiliar, and you give it, substances that would potentially be nutritious for that organism that it could eat, but are completely unfamiliar, then it might not recognize them as food. And then your description of like the motions of the organism will be completely like incorrect as a description of the relationship of this organism to its food. So this supposedly objective account of the organism's behavior actually misses like the most important aspect of the organism's relationship to its environment, which is always mediated by like this ability to recognize or to understand different aspects of the environment. So it's only if the organism is in an environment that it understands, or in which it is capable of recognizing what sort of value the different elements of the environment have for it, in terms of are they potential food, are they potential mates, are they potential predators, etc. It's only in that environment that you can actually like describe the organism's behavior in a way that makes sense. If you have the organism in some completely unfamiliar environment, it will probably just sort of move around in a completely random way that has no like structure to it, and so your whole sort of descriptive biology project kind of falls apart. So this is one sort of problem with this project of like reducing biology to this like objective description of behavior, or objective description of the physical functioning of an organism. And then another sort of issue with this, or maybe a related or another way of expressing the same issue, is that like when you do this kind of purely descriptive account of biology, which is supposed to be objective, then you have no way of distinguishing what is like important, or what is relevant to the organism versus what is just sort of random or accidental. So like even if you are studying an organism in its own sort of normal environment, where it recognizes what is food and what is not, the physical description of the behavior of the organism involves all sorts of more or less accidental circumstances that like it moves towards this food source and not the other one that is like equally distant and equally appealing. It just picks one more or less at random, or like does it pick up the piece of food with its left hand or its right hand or whatever. Like all these sort of contingent bits of decision making that the organism has to perform to actually realize this action. You have no way of saying that like which hand it uses to pick up the piece of food is completely irrelevant from a biological perspective, whereas the fact that it picks up this portion of matter and not this other portion, because the other portion is not a suitable food source, that is important. So like just the sort of purely descriptive account of the behavior of like the motion of the limbs of the animal is is incapable of like picking out why some elements of that description pick out something that is actually important and relevant to the to understanding the animal's behavior, and why some other portion of that movement sequence is like completely contingent and accidental. So like Angus has put in the chat here that like even so, if even like describing the motion, I don't know, you're studying a squirrel or whatever, you make a decision as an observer to say that like the motion of the limbs in moving the squirrel from one spatial location to another in relation to like the ground or the trees or whatever is what's important, and like not the say the blinking or like the twitch of the tail or whatever. Like you are just by describing the the motion of the squirrel in terms of its walking movement, you're already picking out some element or some aspect of the physical situation or the change in this spatial temporal location that we identify as a squirrel. We're already like picking out certain elements as being important or relevant and others as being irrelevant. If you brought a scientist to study squirrel behavior, and all they did was like count how many times the tail twitched over the course of an hour or whatever, you would say this is a pretty pointless investigation. And they probably wouldn't get much in the way of research funding for their next project and so on. Whereas someone who like identifies the movements of squirrels, how they move from one tree to the next, and like what food sources they visit and so on. Like this is maybe at least something that has some relevance to the understanding the life of a squirrel and its biological, the structure of its behavior and so on. So like just the most basic decision of like what elements of the evolution of the squirrel system are we actually interested in studying and accounting for. Even at that level, you're already making a decision about what's important and what isn't, and you can only really do that in a principled way if you have some sort of grasp of like what it is to be a squirrel, or what a squirrel life consists in, as opposed to just sort of doing this physical description of like, or this like purely supposedly objective description of like the changes in the squirrel system over time. Like even if that were possible, like in principle, you would still need to like have a decision about which of those elements are actually important and interesting to study in the first place. Yeah, and this is an interesting comment from Bats here also about like for most purposes when you're doing biology, you can essentially neglect astronomy, right? Like the position of Sirius is like not relevant to determining whether these birds will lay eggs or not. You can completely ignore it. But then there are certain cases where something like the tides, for example, have an obvious impact on fish and other marine organisms, and the tides, of course, have to do with the relationship of the Earth and the Sun and the Moon. So there are these sort of lunar cycles that can have an impact on the way certain organisms behave. And there's even evidence that certain birds are sensitive to the magnetic field of the Earth and use it for navigation in their migrations, for example. And the magnetic field of the Earth is not static; it moves around. Like the poles, the position of the North and South Pole, magnetic North and South Pole of the Earth moves over time. And so, you could look at like the relationship, like does the movement of the magnetic field affect the pattern of the migration of birds, for example? Like, does their course change as the magnetic field moves, for example? That would be something that would be potentially worth studying. So you can't necessarily know like at the outset which elements of the environment actually are relevant and which ones are not, but you have to so it's a kind of complicated process because you have to sort of presuppose at the outset that something is important. You can't just sort of do this pure passive description of every single element of the environment. There's infinitely many elements of the environment that you could in principle describe. Like you could, I don't know, maybe you'd want to study like is there a correlation between like what is on the headline of a newspaper and what the birds are doing or whatever, like some sort of absurd correlation like that. You could Yeah, maybe there would be something interesting to find there. But yeah, you could find, or like, I don't know, correlations between like traffic lights and the movement of snails or something. Yeah, you could do whatever kind of absurd description you want. There's infinitely many things you could potentially think might be um, relevant to understanding the behavior of animals, but like in practice, of course, you can only pick a finite number, and so you have to pick some. You have to have some idea at the outset that this is going to be relevant and this is not. But then you have to also, like, in the course of your investigation, be open to sort of changing your understanding of what is relevant. You might, like, at some point discover, actually traffic lights are important to the movement of snails somehow. I don't know, maybe because of the way that cars follow the traffic lights and then snails avoid the cars or something. I don't know. But yeah, so maybe there is a correlation that wasn't obvious at the outset. But yeah, so like you have to sort of start from yeah, maybe I should apply for a grant for this project. But yeah, so you have to at least have some idea at the outset that this is something that I think is important, that I want to look at. But then over the course of your study, you might have reason to think that some other factor is actually more important than the one you started with, or at least is like a secondary factor that affects the way that the first factor operates, etc. So like, yeah, that's this sort of constant cycling between like thinking that something is an important factor, and then evaluating how important it is, and then seeing whether other factors might also be important, etc. So yeah, you can't like at the outset include everything, but then you also have to sort of be open to including anything later on as you progress in your study. So yeah, this is sort of a long sort of account of this kind of process, but yeah, there's this historical progression in the sense of like trying out different alternatives, but rather than just sort of passively accepting every single piece of information that could potentially come your way and trying to like fit them all together. There's this like selection process that you're constantly engaged in as someone who's trying to study the behavior of an organism. And then also this is interesting because in some sense this sort of mirrors what the organism itself is doing, right? Like the organism is selecting certain aspects of the environment out of all the billions of different signals that the organism could respond to, of like the patterns of light and sound and chemical flows through the air or the water, etc. The organism ignores the vast majority of these. It just doesn't care about any of them, except for the small number that identify things that are important for that organism, like food or predators or a mate or whatever. So in the same way that the organism is selecting certain aspects of the environment as important or relevant, we as researchers looking at the organism also make a selection out of all the infinitely many things that we could study, and we hope to be able to identify what it is that the organism is selecting by ourselves doing another selection of all these different elements. Okay, let's go on to the next bit, and I can read this one. If, on the contrary, we want to maintain the properly biological categories as constitutive of the organism, we would be brought back to a sort of vitalism. We have accepted the fact that vital actions have an autochthonous meaning, as it were. The partial phenomena which physical-chemical analysis intercepts in the living organism are bound together by means of an original relationship. It is no longer a question of the reciprocal determination of the physicist, who ideally derives each of them from the others. They all participate in a single structure of behavior and express the organism's manner of modifying the physical world and of bringing about the appearance in the world of a milieu in its own image. The individual as a, quote, specific capacity of reaction, unquote, is an ultimate category or irreducible model, Urbild, of biological knowledge. As soon as we try to predict the vital reactions of a given organism beyond statistical determinations, the individual coefficient which must be taken into account is, quote, a specific structure which belongs to it with an internal necessity, unquote. What quantum physics has doubtless taught us to introduce quote-unquote a-causal givens into our image of the physical world, beyond which there is no reason, in principle, for affirming a causality of the classical type, and the physicists themselves have made the comparison. But we have not restricted ourselves to saying that the organism was a-causal. By accepting the fact that the organism itself modifies its milieu according to the internal norms of its activity, we have made it an individual in a sense which is not that of even modern physics. We have given a positive content to a-causality, while the physicist limits himself to registering it as a fact and circumventing the obstacle by means of indirect methods, would permit a new cluster of mathematical relations to be thrown over the A causality. As we have described it, organic structure is not just one of these de facto structures which physics encounters. It is a structure in principle. In order to maintain definitively the originality of vital categories, it would be necessary to make every organism a whole which precedes its parts, to find in it the simple act from which the partial phenomena derive their being, to return therefore to the notion of vital élan. But the idea of signification permits conserving the category of life without the hypothesis of a vital force. The resistance of the concrete given to the approximate laws of physics is anonymous, as it were. It is the opaqueness of the fact, the shock of the unexpected result, or the experience of an inexpressible quality. The incompleteness of lawful knowledge does not oblige physics to grant another mode of knowledge because the uncoordinated residue does not lend itself to any verifiable determination, except perhaps those which science will obtain later by the invention of new laws. The law remains therefore the model of all truth in physics. But on the contrary, the quote-unquote non-relational ground, which explanatory biology comes up against, is represented to us by positive characteristics. It is the revelation of objective relations of a new kind. The local electrical charges in an ellipsoid conductor were determinable in terms of the coordinates of the point considered, of the size of the axes, and that of the total charge. Local phenomena are not united in this manner in an organism, that is, by submission to a single law. Motor reactions, temperature, and the proportion of calcium and kalium are linked by their common appropriateness to the organism's mode of preferred activity. A law in a physical system gives at least the probable value of the present state in terms of the immediately preceding state, that of the local state in terms of the total state. When this double determination is impossible, the physicist introduces empirical coefficients, indivisible quanta of energy, which express and do not explain the behavior of the atom. The organism is distinguished from the systems of classical physics because it does not admit of division in space and in time. Nerve functioning is not punctually localizable. A kinetic melody is completely present at its beginning, and the movements in which it is progressively realized can be foreseen only in terms of the whole, as we have established above. The organism is also distinguished from the systems of modern physics because, in physics, unities of indivisible behavior remain opaque givens, while in biology they become the means of a new type of intellection. The particularities of an individual organism are more and more closely connected with its capacity for action. The structure of the body in man is the expression of character. The unity of physical systems is a unity of correlation, that of organisms a unity of signification. Correlation by laws, as the mode of thinking in physics practices it, leaves a residue in the phenomena of life which is acceptable to another kind of coordination by meaning. The same reasons which make a completely deductive physics chimerical also render a completely explanatory biology chimerical. Right. So here, this is like the other side of, the other sort of error. So like if we, I don't know what kalium is. If someone can look that up, that would be interesting to find out. So the other side, so like if we reject this idea of like a purely descriptive biology that would just sort of, collect a bunch of facts and then like, identify the correlations between these facts as like an explanation of the behavior or a way of understanding the behavior of organisms. The other side would be like this sort of vitalist in the bad sense account of behavior. It would be like this idea that there's this sort of life force or vital force that is like additional to physical forces or physical interactions. So like a living being is alive because not because of like the interactions of the chemicals that make up its body, but because there's this life force that sort of directs the way that these chemicals are interacting with each other or something like that. And of course, the objection to this kind of I guess naive vitalism has always been that it doesn't really explain anything. It's just giving a name to the problem, right? So like you have a living being, which is this complicated structure of interacting chemicals, and you want to know like why, like what is it that makes this living being alive, or how is the structure of these chemicals regulated, and what makes it interact in this exact way. And then you say, oh, there's a vital force that does it. Well, this vital force doesn't really, like you could just give that same explanation for just about anything. It doesn't really tell you what, it doesn't get you any further in terms of understanding the phenomenon. And and sort of the traditional reference of this is from Molière's Dormitive Virtue, where he's sort of making fun of scholastic philosophy, and he has a student who is being examined by the professor, and the professor asks, why does opium make people fall asleep? And the student says, because of its dormitive virtue. And so, dormitive virtue is just the capacity to make people fall asleep. And so it's just a completely circular explanation. just gives the name to the property that you're trying to explain. So this vital force would be essentially the same kind of concept as the as normative virtue, right? So you say, what is it that makes things alive? The vital force. And what is the vital force? The vital force is what makes things alive. So you haven't really uh, gotten any further. But yeah, um, what we want to do is not to like this kind of postulation of like a vital force or something over and above the physical level that would bring about the life of living beings is not really it's not a sort of an explanation. It's just sort of naming the problem in a new way. And so what we want to do is grasp something like the signification in like an immanent sense, as not as something. So signification or the meaning of a behavior is not something additional to the physical interactions that bring about that behavior. It's something that is realized by those physical interactions. It's something in those physical interactions, and sort of being able to understand how is it that a signification can be immanent to physical or chemical interactions without being reducible to them. That's sort of the core like intellectual problem that we're trying to resolve here. And so like part of what he's doing in this bit is to sort of contrast this with other forms of explanation. So like the example of like a holistic explanation that he gave a while ago, we saw maybe a month or two ago, was this idea of like an electrical field. So you have a charge in a certain region which produces a field, and there's sort of holistic nature of this field in the sense that every point of the field connected to all the other all the other points. So like the field is not like made up of sort of individual atomic elements. It's like a structure that all the different parts are sort of cohesive in that sense. But at the same time, this is not really this is not a meaning. Like the kind of holism that is characteristic of biological organisms is not the same as this holism that is present in the case of the electrical field, because in that case, the field, there's this simple law that relates, or a relatively simple law that relates the local and the global levels, or the local and the global patterns of the field. So like the charge at one location and the structure of the field are related to each other in the, you can give an equation that relates them to each other. Whereas in the case of the organism, you can't give like an equation, or it's very difficult to give an equation for how like its behavior in one situation or one kind of environment will relate to its behavior in a different situation, and how those are all related to like the overall pattern of life of the organism. There's no sort of law-like connection between the local reactions of an organism and the global pattern of behavior of the whole organism. You can only understand the response of an organism to a particular situation insofar as you have this grasp of the intrinsic biological meaning of that situation. So whether the organism perceives this object as food or a threat or whatever. So you have to use these biological categories already to understand even the local level, and you can't sort of make this simple law-like connection between the local level and the global level like you can in the case of the electrical field. And then he brings up sort of in passing this quantum physics and the sort of indeterministic nature of quantum physics. So like and this was relatively new when he was writing, but of course one of the properties of quantum physics that is different from classical physics is that prediction in quantum mechanics is intrinsically probabilistic, in the sense that you if you're studying the decay of a radioactive substance, for example, you can give an equation for the probability that any given atom of that substance will decay over a certain amount of time. We have like the half-life of different radioactive substances. It says that out of this sample of uranium or whatever, half of it will undergo radioactive decay in this amount of time. But if you take one specific atom of uranium you can't. There's no way of predicting when it will decay. So you can give a statistical estimate for like a whole aggregate of uranium atoms, but any one atom, you can never give an account of why it decayed at this time and not at another time. Um, uh, but what Merleau-Ponty is going to suggest here is that this is still not really this is not really the same kind of explanation that we get in biological phenomena. So we at the level of biology, we again don't have this sort of causal law like we do in classical physics. But it's also not just a purely sort of statistical law. So we're not like when we um, when we look at the behavior of organisms, we don't just sort of suppose that they will randomly decide that something is food or not food. We have like um, sort of a grasp of how the organism understands its environment or how it's likely to respond to the environment. So this sort of acausal or non-law-like behavior of the organism is also not just a random or statistical um, sort of evolution of the animal system. It's not the same kind of explanation as like in quantum mechanics. So this distinction between the biological and the physical in terms of like the kinds of explanations that we give is not restricted to a comparison with classical physics. It also applies to quantum physics. So the account of animal behavior or this explanation or grasp of an animal's behavior in terms of biological categories is acausal, but it's also not probabilistic in the sense of quantum physics. Okay, so we can go on to the next bit. If someone wants to read from Nothing Justifies.
I can read. Nothing justifies postulating that the vital dialectic can be integrally translated in physicochemical relations and reduced to the condition of an anthropomorphic appearance. To affirm this would be to reverse the logical order of scientific thought, which goes from that which is perceived to that which is correlated, without one's being able to follow the inverse path and make the pros hemas, I think, order rest upon the eath auto order. The significance and value of vital processes, which science, as we have seen, is obliged to take into account, are assuredly attributes of the perceived organism, but they are not extrinsic denominations with respect to the true organism. For the true organism, the one which science considers, is the concrete totality of the perceived organism, that which supports all the correlations which analysis discovers in it, but which is not decomposable into them. It is true that the convergent efforts of intellectualism and mechanism withdraw any original determination from the perception of the organism, but both in psychology and biology, the apprehension of structure should be recognized as a kind of knowing, which is irreducible to the comprehension of laws. Here let us say only that the perception of the living body, or as we shall say from now on, of a, quote, phenomenal body, unquote, is not a mosaic of just any visual or tactual sensations which, associated with the internal experience of desires, emotions, and feelings, or understood as the signs of these mental attitudes, would receive from them a vital signification. Every theory of quote-unquote projection, be it empiricist or intellectualist, presupposes what it tries to explain, since we could not project our feelings into the visible behavior of an animal if something in this behavior itself did not suggest the inference to us. But it is not the resemblance of our own gestures to the gestures of the other person which can give to these latter their expressive value. A child understands the joyful meaning of a smile long before having seen his own smile, that of menacing or melancholy mimicry, when he is never executed and to which he has never executed, and to which his own experience can therefore furnish no content. Finally, the living being is known long before the inorganic, which is ordinarily expressed rather poorly by speaking of infantile animism, and it is an anachronism to consider the perception of living beings as secondary. The gestures and the attitudes of the phenomenal body must have, therefore, a proper structure, an immanent signification, From the beginning, the phenomenal body must be a center of actions which radiate over a quote-unquote milieu. It must be a certain silhouette in the physical and in the moral sense. It must be a certain type of behavior. In fact, modern psychology has brought to light this immediate apprehension of structure, which is the condition of possibility of all judgments of recognition, as well as of all associations of ideas. The physiognomy of the face in the writing, thoughts, brain, and gestures of a man present intrinsic analogies which explain, along with the famous unreasonable antipathies, the success of reconstruction tests, in which a subject must designate the profile which corresponds to a voice, and the writing which corresponds to a physiognomy. Likewise, one finds immanent to the phenomenal organism certain nuclei of signification, certain animal essences, the act of walking toward a goal, of taking, of eating bait, of jumping over or going around an obstacle, unities which reflexology, as we have seen, does not succeed in engendering from elementary reactions, and which are therefore like an a priori of biological science. It goes without saying that this apprehension of structure is neither complete nor exact in common perception, and when one speaks of an quote-unquote intuition which grasps them, that one does not mean that this intuition is innate. So like in the last section on the physical order, the Merleau-Ponty sets up these antinomies of here mechanism and vitalism, each of which he sees as incapable of, or being unsatisfying for various reasons. It's in their explanation of the behavior of the organism, kind of on the order of being, but which are explicable if we start from perception. So the physiological or the physicochemical explanation is like the concretion in knowledge of the phenomenal body, which is, I think, ultimately for Merleau-Ponty irreducible to the causal explanations, but not because there's a transcendently real vital force in the organism, because there are these, I guess, perceptual a priori in our interaction with other living beings, which are complemented by but not reducible to the physical understanding.
Yeah, sorry, I was distracted by looking up the Greek here because there's an error in whatever. Sorry, that was probably not worth tracking down. This bit about the physiognomy and all that is a little bit concerning. I'm not sure to what extent we want to believe that there is some sort of connection between someone's face and their intellectual life and so on that leads to some particularly repugnant intellectual engagements. But there are, like, so leaving aside the physiognomy thing, but there's definitely, like, if you think of someone's handwriting, for example, I think we would want to acknowledge that there's some sort of connection between, say, handwriting and personality. In that, if you like presented samples of handwriting to people who like didn't know who had written them, and then you had like some sort of personality description of this person, or like description of their biography or whatever, I think people would probably be able to match the person to the handwriting sample with a better than chance success rate. Probably not perfectly, of course, but like it's not completely random that this handwriting corresponds to this biography of the person. There would be some sort of way of guessing which handwriting sample matches which person. But what exactly this connection is obviously very obscure and would be very hard to sort of figure out, like be able to understand how exactly someone's personality is manifested in their handwriting. Oh, sorry, I was just talking on mute. Sorry, I was just saying we have time for one more reading. But I forgot where we got to exactly because I went back to check the Greek there.
I think we're at the bottom of 157. So at the precocity of the
precocity.
perception.
Right.
Yeah.
Okay. Does someone want to pick up from there?
Yeah, I can read another one. The precocity of the perception of living things served us here only to exclude the constructive and projective explanations of classical psychology. It is precisely descriptive biology which, starting with the imperfect intuitions of common perception, reorganizes and corrects. There is an exchange of service between the description of the phenomenal body and causal explanation. Common knowledge contains, for example, a rich and confused notion of male and female, which connotes certain behavioral constants, a general attitude recognizable well beyond sexual behavior properly called. It is very unlikely that this notion is constituted in the experience of each one of us by the inductive rapprochement of a large number of isolated facts. On the contrary, it is likely that it was read in a single glance and revealed in a facial expression, in a gesture. The discovery of causal correlation, for example, endocrine, which subtends the ensemble of sexual characteristics, has not only the effect of, quote, completing the common notion, it can also lead us to modify our view of the male and female and integrate with it certain partial attitudes which had eluded common knowledge. But in any case, to understand these biological entities is not to note a series of empirical coincidence. It is not even to establish a list of mechanical correlations, to unite the ensemble of known facts by means of their significations, to discover in all of them a characteristic rhythm, a general attitude towards certain categories of objects, perhaps even towards all things. Thus it is necessary in the sense to go beyond man. These remarks cannot serve to justify a vitalism, however. Even the refined vitalism, the relation of the vital élan to that which it produces, is not conceivable. It is magical, since the physico-chemical actions of which the organism is the seat cannot be abstracted from those of the milieu. How can the act which creates an organic individual be circumscribed into his whole, and where should the zone of influence of the vital élan be limited? It will indeed be necessary to introduce an unintelligible break if one prefers to say that matter consists of disintegrating. The relation of life which is becoming to life which is integrating is no more comprehensible. But the critique of mechanism leads back to vitalism only if it is conducted, as often happens on the plane of to reject the dogmatic thesis according to which the unity of the organism is a superstructure supported by a really continuous chain of physico-chemical action, would then be to affirm the antithesis, also dogmatic, which interrupts this chain in order to make place for a vital force. Just as before Kant, the negation of infinite divisibility was equivalent to the affirmation of an invisible This is indeed the case as long as one...
You can continue a bit.
It is inconceivable. Only a little bit there. It is inconceivable, this is the mechanist argument, that an existing physical or chemical action not have its real conditions in other physical or chemical action. But this is the vitalist argument, since each constant chemical reaction in the organism, for example the fixation of oxygen on the hemoglobin of the blood, presupposes a stable context, which itself presupposes another one. The physico-chemical explanation always seems to be deferred. Since no law is unconditional, it is difficult to see how they could be so together. And since there do exist organisms in fact, it seems necessary to relate the multiplicity of phenomena to simple act of a vital élan.
Right. So here it's again this sort of rejection of vitalism in the sense of something something that is distinct from matter or distinct from the physical world. So a second aspect of the world or a second set of principles governing the world. We have to sort of understand the nature of the living being as distinct from a physical property of portions of matter, but not as something separate from that matter. So a living being is, somehow the life of a living being is somehow realized or manifested in the interactions of chemicals that make it up, but it's not sort of reducible to those interactions. So that's this sort of middle ground, or this threading the needle that we have to sort of make sense of as we continue reading this book.
I like this in this paragraph at the bottom of 157 and top of 158, the idea that it's these what he called nuclei of signification aren't innate, and they also can be, he says, they can be completed by discovery of causal correlations, and yet the causal correlations always relate back to the perceived unity. Yeah, it kind of makes me think of some of the criticisms of so-called folk psychology, and it seems like it would be a way to I guess I'm trying to think of how to say this, to I guess replace the manifest image, or criticize, like in this case, like folk biology, and move to a more scientific understanding, but also without abandoning the perceptual situation that I find satisfying.
Yeah, it's a kind of an attempt to do justice to both the capacity to learn about the world through scientific study and investigation of aspects of the world that are not immediately obvious to us, but also to the other side, which is our engagement with the world separate or before we learn about science, whether historically or in the life of a particular person. So trying to see how these two, like how to do justice to both aspects of our understanding of the world, without saying that one is sort of defective or less important than the other.
We need a Bergsonian in here to go to bat for Bergson. I know that Ponty criticizes Bergson, I think, a few times in his writings. I think he also does it in Phenomenology of Perception. I'd be interested to hear the Bergsonian rebuttal.
Yeah, I mean, I know that there's been some study of like what his relationship to Death's Son was and so on, but it's not something I've looked into in much detail.
It definitely might be the case that that over the course of Bergson's life, more and more doing the things that would be relevant. Whereas maybe, I was thinking maybe taken, oh my gosh, purely from his early thought, it might not be as. I still have to sound better. That's all I have. Sorry for my voice.
Yeah, Baksan is, I think, more subtle and sophisticated than it sometimes seems, sort of at first glance, because he has this sort of like elegant writing style, and it seems like he's sort of just, giving these like sort of. At first reading, he might seem sort of superficial, I think, but then if you sort of look more carefully and sort of think through what he's talking about, it's actually quite sophisticated. So yeah, I would be hesitant to. Sort of attribute this naive vitalism to him in the way that Merleau Ponty is doing here, but definitely I think repays looking at his work carefully and analyzing it and taking it seriously.
I love figures like Bergson because they play the foil so efficiently that there's always work to be done to disambiguate erroneous assumptions. So I should get more into Bergson, definitely.
Yeah. Okay, cool. We can stop here, and I think next week should be good to continue. I don't think I have any races to run next weekend, so thanks everyone for your contributions, and hope to see you next time.
Sounds good. Thanks, Nan. Thanks, everyone.